Hello to all my geometry friends. Today, I'm here to provide some guidance for you to help determine which trig function to use when solving triangles. So let's get straight to it. Zorg, would you like to ask a question?
Yes, Mr. Waite. When should I use sine?
Excellent question, Zorg. Since the sine of an angle is equal to the ratio of the side length of the side opposite the known angle divided by the length of the hypotenuse, we use sine if we know one of those side lengths and need to know the other. Or, if we know both of those measures but not the angle, we can use the inverse sine of the ratio of side lengths to get the angle measure. We will look at using the inverse functions in a minute. Remember to make sure your calculator is in degree mode before you start. In this case, the sine of 63 degrees equals 12 divided by h, the length of the hypotenuse. Apply some algebra 1 and you have 12 divided by sine of 63 degrees. Going to the calculator, we get an approximation of 13.468 feet.
Mr. Waite, when should I use cosine?
Another excellent question, Zorg. Since the cosine of an angle is equal to the ratio of the side length of the side adjacent to the known angle divided by the length of the hypotenuse, we use cosine if we know one of those side lengths and need to know the other.
If I may, Mr. Waite. In this case, the cosine of 57 degrees equals 7 divided by h, the length of the hypotenuse. Apply some algebra 1 and you have 7 divided by cosine of 57 degrees. Going to my calculator, I get an approximation of 12.853 feet. But Mr. Waite, how do I solve for the angle measure if I only know side lengths?
Another super brilliant question, Zorg. We use the inverse of the trig function to solve for the angle measure just like we use the inverse of multiplication, which is division, to solve an equation where the unknown is being multiplied by some number. Let's look at an example. In this case, we are trying to solve for angle measure theta. We know the length of the side opposite theta to be 65 feet and the length of the side adjacent to theta to be 34 feet. Since the tangent of theta is equal to the ratio of side opposite divided by side adjacent, we get tangent of theta equals 65 over 34. Then we take the inverse tangent of both sides to get the angle measure. You don't need to write this all out each time you use an inverse trig function. Just take the inverse trig function of the appropriate ratio. You can see that I got approximately 62.387 degrees for the measure of theta.